Hello everyone, today we're going to learn about ionic and covalent bond. First, we're going to learn about ion. Ion refers to an atom that carries a charge. There are several types of ion. So, types of ion according to the charge. There are two types of ion according to the charge. The first one is cation. Cation refers to a positively charged ion, and an ion refers to a negatively charged ion. And for the second type, types of ion according to the number of atoms. They are monatomic ion and polyatomic ion. Monoatomic ion is an ion consisting of only a single atom, while polyatomic ion is an ion consisting of two or more atoms. So we'll look at these examples. First one is ammonium ion, or NH4+. We can see that there's a plus sign over here. So this means that it is a positively charged ion. So it is a cation. And because there are two atoms, nitrogen and hydrogen, so it is a polyatomic ion. So combine polyatomic and cation, ammonium ion is polyatomic cation. For the second example, phosphide ion, P3 negative. So this ion is negatively charged. So this is an anion. And there's only a single atom, which is phosphorus. So this is a monoatomic ion. So combining monoatomic ion and anion, phosphide ion is monoatomic anion. Next, we're going to talk about Lewis dot symbol. Lewis dot symbol is the symbol of an element with one or more dots representing the valence electron of the element. So if an element has a valence electron of 2, there will be 2 dots surrounding the element. We'll look at these examples. For calcium, if you look at the periodic table, we know that calcium has an electron of 20. So the Bohr's model of 20 is 2882. Therefore, the valence electron in the last shell is 2. So there's 2 dots surrounding calcium. So these are the Lewis dot symbol of calcium. For number 2, we have selenium. We know that selenium has an electron of 34, and the Bohr's model of 34 is 28186. So the valence electron is the electron in the last shell, which is 6. So there's 6 dots surrounding selenium. Now we're going to talk about Octet Rule. Octet Rule states that for atoms to be stable, they tend to achieve the valence electron of a noble gas, which is equal to 8. So we'll use the examples in the last slide. For calcium, notice that the valence electron is 2. So in order for its valence electron to be 8, we can receive 6 more electrons so that the last shell will be 8 electrons. Or we can release 2 electrons, so the last shell will have 8 electrons. So what will we choose? Release 2 electrons or receive 6 electrons? We will choose to release 2 electrons because it is easier, because 2 is lesser than 6. So calcium will release 2 electrons. And for selenium, for 6 to become 8, we need to add it by 2. So selenium will receive 2 electrons. And now we're going to talk about Ionic Equation. Ionic Equation is an expression of the formation of ion by gaining or losing certain of electrons. So from the last example, we know that calcium will release 2 electrons in order to become stable. So we can make an expression with this. So calcium, it releases 2 electrons, so minus 2 electrons, it becomes calcium when release 2 electrons, so it has 2 more protons than electrons, so it becomes cation. So Ca2+, because it releases 2 electrons. And in an ionic equation, we don't like to have negative sign in the equation, so we transpose this negative 2 electron to the right side, so it becomes positive 2 electron. calcium, an arrow sign, calcium 2 plus 2 electron. And now for the second example, because selenium receives 2 electrons, so selenium plus 2 electron becomes selenium 2 negative. So when selenium receives 2 electrons, it has 2 electrons more than proton. So it is an anion. So selenium 2 negative because it receives 2 electrons. So now we're going to talk about chemical bonding. Chemical bonding happens when 2 or more atoms join together in order to become stable, forming a molecule. There are 2 types of chemical bond. First one is ionic bond. Ionic bond happens between a metallic and non-metallic ion. So for example, we have magnesium nitride and sodium chloride. You can see from the periodic table of elements that magnesium is a metal and nitrogen is a non-metal. And for sodium chloride, natrium or sodium is metal and chlorine is non-metal. For the second type of bond, we have covalent bond. Covalent bond happens between non-metals. So the examples are carbonate and ammonia. So for carbonate, both carbon and oxygen are from the non-metals, and for ammonia, nitrogen and hydrogen are both non-metals, nitrogen and hydrogen. Now we're going to talk about Lewis dot structure for ionic compounds. So now we're going to look at some examples. So example number 1, we have lithium bromide. We know from the periodic table of elements that lithium has a valence electron of 1. So 1 dot surrounding lithium. And bromine has 7 valence electrons. So 7 dots surrounding bromine. And in ionic compounds, they become stable by giving and receiving electrons. So lithium will become stable if lithium gives its electron to bromine. And bromine will be stable if bromine receives 1 electron from lithium. So the dot here will go to here. So it becomes lithium with no dots because the dots is transferred here, and bromine with 7 valence electron originally and 1 electron from lithium. So because lithium releases 1 electron, it becomes a positive ion. So lithium plus, and because of bromine receiving 1 electron, so bromine becomes negatively charged ion. So bromine negative. For example number 2, we have sodium oxide, and we'll first draw oxygen because oxygen will be the central atom as it has lower number compared to sodium. So oxygen has 6 valence electron, so 6 dots surrounding it, and sodium has 1 valence electron. So in order for sodium to be stable, sodium will give its electron to oxygen. So from the left side and the right side, the dots will go to oxygen. So this will become sodium. It has no dots because the dots is already transferred. And oxygen. Oxygen now have 6 electrons originally and 2 more electrons from sodium. So it follows the Octet Rule. Now because sodium releases 1 electron, it now becomes a positively charged ion. And because oxygen receives 2 electrons, it becomes negatively charged ion. So oxygen -2. Now we're going to talk about Lewis dot structure for covalent compounds. So we're going to look at some examples. So example number 1, bromine. We know that bromine has a valence electron of 7, so 7 dots around bromine. And in covalent compounds, the atoms become stable by sharing their electrons with each other. So each bromine needs 1 electron to be stable. So they will share each electron. So this will become like this, and they will share in the middle one. So we can see that the bromine have originally 7 electron and 1 electron from sharing. You can simplify this structure by replacing the pair of electrons shared by dash. So bromine, bromine, and the shared electrons replaced with dash. Now this single dash is called single bond. And the second example is carbon dioxide. So we'll draw carbon first in the middle, as it has only 1, which is less than 2. So we know that carbon has 4 valence electron and oxygen has 6 valence electron. So oxygen needs 2 more electrons to be stable, while carbon needs 4 more electrons to be stable. So each oxygen will share 2 of their electrons with carbon. So this will become, so in here, there are sharing of electrons in here. So both oxygens have originally 6 electrons and another 2 electrons from carbon, while carbon originally has 4 valence electrons. Now it receives 4 more electrons from sharing. We can simplify this by replacing a pair of shared electrons with a dash. So because they share 2 pairs, so there are 2 dash. So carbon and 2 dash. This 2 dash is called a double bond. Now for the third example, we have nitrogen. So nitrogen and nitrogen both have 5 valence electrons. In order for them to become stable, they need to share 3 electrons. So there are 3 pairs of electrons in the middle, so we can see that both nitrogen have originally 5 valence electrons and 3 more electrons from sharing, so it satisfies the octet rule. And because there are 3 pairs of electrons shared, we can simplify this to be 3 dash. This 3 dash is called triple bond. A covalent compound could only have a maximum of triple bond, so it could have single bond, double bond, or triple bond. Next, we're going to talk about octet rule exceptions. Some compounds does not follow the octet rule, but they actually exist in this world. So we're going to look at some examples. The first one is sulfur hexabromide. So sulfur as its central atom and bromine surrounding sulfur are bond with sulfur with a single bond. We can see that all bromine satisfies the octet rule because there are 1, 2, 3, 4, 5, 6, and 7, 8 electrons. However, sulfur does not follow the octet rule. You can see that sulfur has a valence electron of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12 electrons. So sulfur does not follow the octet rule. For the second example, we have boron trichloride. So boron as its central atom because the number are less compared to chlorine, and chlorine surrounding them and joined by a single bond. So we can see that chlorine follows the octet rule because it has 1, 2, 3, 4, 5, 6, 7, 8 valence electron. However, boron does not follow the octet rule as it only has 1, 2, 3, 4, 5, 6 electron. So these two compounds does not follow the octet rule, but they actually exist in this world. This is all for today's lessons. Thank you and see you tomorrow.